This video contains the solutions to the take-home problems number 1 handout. So this first question asks us to convert 0.036 into a fraction written in lowest terms. So the basic idea here is that we can think of 0.036 as a fraction that looks like 0.036 divided by 1. Now normally we don't like to have decimals and fractions mixed together, so let's see if we can change this fraction so that it no longer has a decimal on the top. Well, if we take that number on the top and multiply it by 10, that's going to move the decimal place one space to the right. But of course, if we multiply the top by 10, we also have to multiply the bottom by 10. So on the top, the effect of multiplying by 10 is to move that decimal point. So now on the top, we have 0.36, and on the bottom we have 10. But of course, now we still have a decimal, so we can multiply by 10 again. On the top, that's going to now give us 3.6 and 100 on the bottom. Still have a decimal, so we can multiply by 10 one more time. And that's going to give us 36 divided by 1,000. Now, we could see that we actually needed to move the decimal place 3 spaces, so we could have just multiplied by 1,000 and done this all in one step. Or if you like, we can multiply by 10 over and over again. Whichever way makes more sense to you is fine. Now, this fraction is not in lowest terms because 36 and 1,000 have some common divisors. You might, for example, notice that both 36 and 1,000 are even numbers. That means they're both divisible by 2. So we can start reducing this fraction by dividing the top and bottom by the same number. In this case, if we divide top and bottom by 2, 36 divided by 2 is 18, 1,000 divided by 2 is 500. Those numbers are still both even, so we can divide by 2 again. On the top now we have 9, and on the bottom we have 250. But 9 is just 3 times 3, and 250 is not divisible by 3. So 9 and 250 don't have any common factors, and so 9 over 250 is our final answer. For the next question, we're doing some fraction arithmetic. So we want to evaluate 2/3 minus 7/10 plus 6/5 and write our answer as a fraction in lowest terms. So what we have to remember here is that when we want to add or subtract fractions, we need to find a common denominator. So we have to find a common multiple of those bottom numbers, of 3, 10, and 5. Now, one way to find a common multiple is to simply multiply all the numbers together. We can take 3 times 10 times 5, and that would give us 150, which is a common multiple. But we can actually do a little bit better here, because a common multiple of 10 and 5 is just 10. 10 is a multiple of 5. And so a common multiple of 3, 10, and 5 would be 30. 30 is a multiple of 3, it's a multiple of 10, and it's a multiple of 5. So what we want to do is rewrite all of these fractions so that they all have a 30 on the bottom. And we're going to do that by multiplying top and bottom by the proper number that's going to get us that 30 on the bottom. So starting with 2/3, what do we have to multiply the 3 on the bottom by to get 30? Well, we have to multiply by 10. And if we multiply by 10 on the bottom, we've also got to multiply by 10 on the top, and that gives us 20 over 30. Next, moving on to 7/10, we have to multiply by 3 on the bottom to turn that 10 into a 30. But if we multiply by 3 on the bottom, we have to multiply by 3 on the top. So now we have 21 over 30. And then finally, 6/5, we have to take the 5 on the bottom, multiply that by 6 to get 30. 5 times 6 is 30, but we have to multiply by 6 on the top as well. So that gives us 36 over 30. Now that we have a common denominator, we can add and subtract these fractions simply by adding, subtracting the numbers on the top. So 20 minus 21 plus 36. 20 minus 21 is -1. -1 plus 36 is 35. So we get 35 over 30. But that fraction is not in lowest terms because 35 and 30 have a common factor, namely 5. So we can divide top and bottom by 5. 35 divided by 5 is 7. 30 divided by 5 is 6. So the final answer here is 7 over 6. All right, next up we're asked to think about the two expressions -4 squared and -4 squared. And really what we're thinking about here is the order of operations. The order of operations here is what we often refer to as PEMDAS, parentheses, exponents, multiplication and division, and then addition and subtraction. So the real question here is involving the parentheses and the exponents. So when we have negative 4 squared without parentheses, the exponent happens first. There are no parentheses, so the exponent is going to square that 4 before the subtraction, indicated by the minus sign, is going to happen. So this means 4 times 4, that's what it means to square, and then you put a minus sign out front. The exponent happens first. So that's going to be negative 16. But if I add parentheses around the negative 4, that means that the number that I am squaring is negative 4. So that means negative 4 times negative 4. And a negative times a negative is a positive. So that one's positive 16. So if I don't have parentheses that include that negative sign, the negative happens after the exponent, because the exponent happens before subtraction. So E comes before S. So we square the 4 and then we subtract. Similar question here. If we have the square root of negative 4 squared and the square root of 4 squared, are those the same or are they different? And what this problem is really getting at is this notion that we have that squaring and square rooting should cancel out. So when we think about negative 4 squared, we think in our heads, well, if I square root a square, the square and the square root should just go away, and so I should just get negative 4. And it turns out that that's not right. We shouldn't really take any shortcuts here. We've just got to think about what this is telling us to do. We've got to think about the order of operations. So let's work from the inside out. Inside that parentheses, negative 4 squared, as we saw in the previous problem, is positive 16. And when we use that square root symbol, we're always looking for the positive square root. So the square root of 16 is 4. Similarly, 4 squared is 16. No negatives there to worry about. And the square root of 16 is also 4. So these expressions are equal. So don't just think, oh, a square root and a square are going to cancel each other out. It's not quite that simple. Final question here, again, working with the order of operations, which I'll write out again, PEMDAS, P-E-M-D-A-S. And as I did before, we want to think about the M and the D as being a group, and the A and the S as being a group. So the way that I read this is parentheses, exponents, multiplication and division, and then addition and subtraction. And that becomes important here. It's not multiplication and then division. It's multiplication division all at once. It's not addition and then subtraction. It's addition and subtraction all at once. So if we take our expression here, 4 plus 5 times 6 divided by 2 times 3 plus 1, we have some parentheses, so we'll deal with those first. Inside the parentheses we have 3 plus 1, and 3 plus 1 is 4. Now when we have two numbers next to each other, we're using parentheses, that means multiplication. So I'm going to rewrite this using the multiplication sign. 6 divided by 2. Rather than with the 4 in parentheses like that, I'm just going to write times 4, just to make it a little easier to think about. Alright, so I did my parentheses, don't have any parentheses anymore, don't have any exponents, ready to move on to multiplication and division. And so multiplication and division happens from left to right. So 4 plus 5 times 6 is 30, and then divided by 2 times 4. And then, continuing to move from left to right, 30 divided by 2 is 15. Move up here because I ran out of room. 15 times 4 is 60. And now I've done all of my multiplication and division. And then finally I have some addition. 4 plus 60 is 64. And so that's my final answer.